Okay, hi there. Dr. Matthew J. Traum here. This is a lecture in our creative ideation module in which I'm going to talk about eliminating impossible concepts. As you guys know from watching my previous videos, if I end up having a deck of slides, it's going to take me more than 15 minutes. I'll break the lecture up into 15-minute segments to give everybody a break at every 15-minute intervals. So that's what we'll do here. The importance of this video is that it covers an element that you'll have to do in your concept design reports, which is called Eliminating Impossible Concepts, where you go through and determine if any of the concepts that you've come up with violate the laws of physics or the laws of the universe. And this sometimes can be a pain point for engineering students because a lot of times you'll get to a concept and you'll realize that it probably cannot be done within the constraints of the customer needs, and you'll feel very strongly about throwing it out. But please don't do that. As we'll see, there's actually some benefit in holding on to those concepts that potentially don't adhere to customer needs, but that don't violate the laws of the universe. Only concepts that truly cannot be done because they violate some fundamental physical law are concepts that you should throw out at this stage in the process. So we're going to talk about these items. So first, we're going to talk about where eliminating impossible conflicts fits into the overall design process. And then I'm going to describe to you what I call unlikely versus impossible concepts, give you a couple of examples, explain why not to eliminate unlikely concepts too soon. And then, because by this point, you're all going to be very uncomfortable, right? You're going to want to throw out some of these unlikely concepts because you know that they do not meet customer needs. So I'll explain very briefly where they do get eliminated in the down selection process of the design activity. So the first thing is let's talk about where eliminating impossible concepts fits into the overall design process. And you guys have seen this before. So this is the design process, engineering design process progression slide that we've talked about. Again, this green dotted line here represents the separation between Mech Design 2 on the top and Mech Design 3 on the bottom. And in Mech Design 2, EML 4501, we're marching through the first 11 steps of what is effectively a 20-step process. And by now, you guys are deep into your CDRs, your concept design reports. And so we've identified the problem. You guys have researched the problem. You've hopefully determined that there is no viable solution that exists today on the market. So you've now converted the customer needs into quantitative metrics. You've begun generating concepts. And before you do step number 6, which is the concept design review, which for you guys is that written CDR report, we do want to do one final kind of filtration step on your concepts, which is to eliminate the impossible concepts. And so it's this step number 5 that we are talking about in this lecture today. But that's where it fits in. It's the final filtration of the concepts before your concept design report is written, or in the case of conventional design work with a customer, you would do a design review with the customer, and the review or the customer would give you feedback as a result of the review on the concepts that you generated. Okay, so let's talk about what I call unlikely versus impossible concepts. So this is going to feel very uncomfortable for you guys because you're going through this brainstorming process right now. You're developing a lot of concepts, and many of them are going to seem like you're going to want to throw them out because they don't appear to meet the requirements of the customer needs. But at this point, please do not throw them out. Hold on to those ideas. They are important. They will give you benefits later if you hold on to them. The only concepts that you should remove from consideration are concepts that violate the laws of physics, right? So things that are truly violations of the laws of the universe. So, things like paranormal phenomenon, it requires some sort of, ghost or something or telekinesis or something to move objects around or to gather information. That one you could throw out. Concepts that involve time travel, having to go backwards in time to achieve something that then propagates forward in time. That probably should be thrown out. And then of course you guys know I'm thermal fluids guy, so my favorite is ideas that violate the second law of thermodynamics. So perpetual motion machines or systems that when you heat them up they get colder, that sort of thing. Systems that reduce the overall entropy of the system and the universe, those also need to be thrown out because you're violating just a basic physical concept. However, do not eliminate an idea just because you think that it's too costly, too silly, fragile, uncomfortable, difficult to make, etc., or that it doesn't, for some reason, line up with the customer expectations. Only eliminate, I've said this and I'll keep emphasizing it, only eliminate the concepts at this stage that violate the physical laws of the universe. All those other silly, costly, ridiculous concepts that are not violating physical laws, please hold on to them. You will need them later. So given sort of that pretty high bar that you have to be violating physical laws of the universe to get eliminated in this stage, it's quite unlikely to disqualify a concept. And a rule of thumb, this is just based on my own experience having taught design for multiple years, there's only about 1 out of 100 concepts that you and your team will come up with that truly violate the laws of physics. So about 1 in 100. So for the concept design report, you guys should be generating something on the order of 100 concepts, right? It's I think I've required 12 concepts, and you might have somewhere between like 5 to 7 subsystems, and so you're getting close to 100 total concepts. And so it is likely that you will probably remove one in this phase of the process. So maybe one will be removed out of the 100 or so that you generate. If you feel like you're eliminating like dozens and dozens of concepts, you're being too conservative with your application of this particular filter. Okay, so let's talk about some examples, unlikely versus impossible concepts. So the first one, just call this example one, involves the 3D bioprinter, which we did in 2019 fall in MEC 2. And the customer need in that case was that the 3D bioprinter had to be able to deposit and extract cells from a liquid-like solid with a linear accuracy of less than 1 cell diameter. So, okay, we're going to attempt to actually quantify that because that, of course, is a qualitative customer need. So the way that we quantified it is we went into the literature and figured out what our various potential customers, what cells they were 3D printing with. And the common ones are fibroblasts, glioblastomas, and pancreatic cancer cells. And so then I looked up from various sources that I have cited here, kind of what the typical diameters of those cells are, and somewhere between 10 to 15, 12 to 14, or 12 to 30, depending on the cell type. And so this is the smallest diameter that I ran into, which is 10 micrometers. And so wanting to not just meet the customer needs, but exceed them, I set my quantitative metric as linear accuracy has to be 9 micrometers or better, right? So that's where I'm going, is 9 micrometers or better. And based on that information, we had one group in fall of 2019 that had a subsystem which they called the X and Y linear motion stage. So this was responsible for moving the deposition tip of the 3D bioprinter around in the X direction and the Y direction inside the liquid-like solid, the print medium. And one of the concepts that they came up with, which I put it in quotes here, the impossible concept, was this idea of moving the X and Y linear motion stage just by hand. So literally just having this material, this block that makes up the stage, and just pushing it around with your fingers to try to get it lined up to where it needs to go. Okay, so the reason that they thought that this concept was impossible and they originally felt like they needed to eliminate it was because 9 micrometers of linear accuracy, that's a pretty precise number, right? So can a human being reliably move something again and again and again by 9 micrometers? So we didn't actually know whether that was viable or not, and so we then went on to, whoops, uh-oh, hang on, my slide is for some reason not lining up where it should. Let me just move this. Ha, there we go. Okay, so we moved on to quantifying the concept by asking the question, what is the smallest distance that a human finger can reliably move an object? And you would think, as I did, that this is like a common thing that people have actually measured and studied in the literature. We spent hours and hours and hours looking for data on this, and interestingly, we could not find anything that described the smallest distance that a human could actually push an object reliably. And so we ended up having to run a series of experiments, and the experiment was pretty simple. We just took a caliper, the one that I'm showing here in this picture, and I set it to 0, and I tried to just push it with my finger and see like how small I could get those motions to be in a reliable way. And it works out that it's about 6/100ths of a millimeter, or about 60 micrometers, is how far the human finger can sort of reliably push something in a repeatable way. So anyway, so that was how we quantified it. Moving on to the next slide, and I've got to move this guy back down. There we go. Not sure why that other slide was weird, but we're back. Okay, so is this concept, now that we've quantified it, is this concept of pushing the XY stage of the 3D bioprinter by finger, is it unlikely, or is it impossible? Well, we found just from our in-house experiments that human fingers can push things about 60 micrometers, and that's of course much larger, about an order of magnitude larger than the 9 micrometers that we set as the quantitative metric for the cell diameter, which is also the linear accuracy of the XY stage. And so we concluded that this is probably something that doesn't meet the customer needs, but pushing things around with your fingers to cause them to move does not violate the laws of physics, right? There's no fundamental law that says that I can't push something along with my finger and cause it to move. And so I would characterize this concept as unlikely, but not impossible, right? Unlikely in that it probably is not going to achieve the set customer needs, but it does not violate the laws of physics. So the key question then to ask is, given what we know now about unlikely versus impossible, should this concept have been tossed out? The answer, of course, is no, this concept should not have been tossed out. And it wasn't. The group kept it in their down selection matrix. Well, we're almost to 15 minutes, so I'll stop the story there. But when we pick back up again in the next video, I'll walk through kind of what happened with that story of human fingers pushing things around in the 3D bioprinter, and show you why, by example, why it's important to not eliminate concepts too soon, provided that they are just unlikely and not impossible. Okay, so take a break, come back when you're done, and we'll pick it up from there. Thanks.